All right, everyone, welcome to the Rowan College of Burlington County Global Studies Lecture Series. This is a continuation of a series of conversations that started in fall 2020. We're now in our third year in global health, environment, and security and key international issues affecting those. This event series is partially sponsored by the U.S. Department of Education's Undergraduate International Studies and Foreign Language Grant Program, a multi-year grant that we have at RCBC with our partner institution, Rowan University, to build global and international studies designations and programs, and courses in high-demand languages such as Arabic and Chinese, along with student activities reflecting those initiatives, including the lecture series here. This is, of course, also hosted by Rowan College, a mid-sized 2- and 3-year college in Mount Laurel, New Jersey, serving the geographically largest county in New Jersey with anywhere from 7,000 to 9,000 students each semester. RCBC has one of the most ethnically diverse student bodies in the state and region, with one of the lowest tuition costs as well. I'm your host for this event in this series. I'm Brandon Chapman, Department Chair of Anthropology and Sociology at the college. And I created the lecture series a few years ago as a part of this grant that was just previously mentioned. And the goal of the lecture series and these events is to bring to Rowan College campus and here today our virtual WebEx campus, top-level scholars, academics, researchers, and industry professionals at all levels of career, early, mid, and late career that are experienced, knowledgeable experts in global health, environment, and security issues, and of course to develop this knowledge and skills in our students at both Rowan University and Rowan College, and to have a dynamic conversation about these key global issues within these areas, and to give our students such avenues to advance their training in these areas. In just a second, I'm going to let a few more people in here to the room. We got some folks waiting. So look for more of these events in the future with multiple speakers coming up this spring 2023 semester. We took fall 2022 off. Just as a reminder, coming up next week, Thursday, February 16th, we're going to have Michael Kimmage from Catholic University of America talking with me about the Russia-Ukraine war and the ongoing conflict over there. March 24th, after our spring break at Rowan College, we're going to have Ahmet Kuru from San Diego State University is going to be talking about his recent book on economic and political development across the Islamic world and the Middle East. And then on April 5th, we have coming back for a second time, he was here a few years ago, Hal Brands from Johns Hopkins Advanced International Studies is going to be talking about his recent co-authored book on U.S.-China relations and Chinese threat and that ongoing situation as well. So this afternoon, we have the pleasure of welcoming Dr. Alex T. Tabarrok to Rowan College. He is Bartley Madden Chair in Economics at the Mercatus Center and also Professor of Economics and Chair both at George Mason University. Dr. Tabarrok has a wide-ranging and extensive research and publication history, including authoring numerous influential and cited pieces about healthcare policy, patent system reform, methods for increasing the supply of human organs for transplant, the regulation of pharmaceuticals by the Food and Drug Administration, the FDA, along with other various topics outside of healthcare policy. He was an advisor to the U.S. government on using incentives to accelerate vaccine production during the coronavirus COVID-19 pandemic, which I believe he may talk about a little bit in detail in his coming talk here. And his papers have appeared in numerous scholarly journals, including Science, the Proceedings of the National Academy of Sciences, the Journal of Human Resources, Journal of Law and Economics, and so forth. And he's also been a contributor and had more popular writings in major publications such as the New York Times, the Washington Post, and the Wall Street Journal. A note on format and agenda here this afternoon. Many of us have been in these meetings where there are occasionally people unintentionally off mute. So just a reminder, at least during Dr. Tabarrok's talk, I do have the power to mute. We haven't had any logistical issues with this before, so we shouldn't have today. And I believe the format, we've done these series events in various formats before. For those of you that have attended before, I think at least a few of you have. And so just a reminder here, he's going to be giving his presentation, and then I will help moderate questions as host to him afterwards. So please stay on mute and off video so we can give the full bandwidth to him during his presentation. And then afterwards, we will be able to take, he'll be able to take questions through me, and we should hopefully have a good conversation and discussion based on the lessons learned here from the COVID pandemic and his experience with it. So with that, and with his title of his talk, U.S. Pandemic Policy Failures, Successes, and Lessons. Let's welcome Alex Tabarrok to Rowan College. Alex, go ahead.
Great. Thank you very much, Brandon. We have a fairly small group today, I'm seeing. So if you do want to send questions, you want to send it to chat. And Brandon, if you decide you want to interrupt and get a question out there, that'd be fine as well, since we have a pretty small group. Okay. So yeah, I'm talking about U.S. pandemic policy, failures, successes, and lessons. And I think it's incumbent to really start with the failures. If you don't know, this picture is of the U.S. memorial to COVID victims, and each one of these white dots is a flag, which memorializes a COVID victim, and the loved ones of the victims would come and write the names and their sort of last words to their loved ones on these flags. You know, we've now had well over 1 million deaths from COVID in the United States. That is more deaths from COVID than from World War I, World War II, Vietnam, Afghanistan, Korea, Iraq, all of the US's foreign wars combined. More deaths from COVID than from all of the US's foreign wars. Only the Civil War comes close, and now we've had more deaths from COVID than even from the Civil War. The deaths, of course, are the most consequential aspect of the crisis, but the economic cost was also extreme. So in just 2 months, in 2020, 17 million people lost their jobs, and the unemployment rate shot up from 3.5% to 15%. Larry Summers estimated that the cost of the pandemic was $7.5 trillion in direct GDP costs and 16 trillion losses overall. And actually, we don't even know the true cost, because the education losses are sort of still to come, the losses to human capital. We don't know how bad long COVID is going to be, the long-term healthcare losses. So the losses are still continuing to accumulate. And of course, we're talking here about something which was worldwide losses. So worldwide, we're talking 20 million deaths at least, and counting. And one of the most really frustrating aspects of the pandemic is that not only was it predictable, but it was predicted. It was predicted in advance, and not just in general terms, but in very specific warnings about the source, location, and the type of the virus. So here is science. Bats are natural reservoirs of SARS-like coronaviruses. Killer flu pandemic is inevitable. World is not prepared. Planning for the inevitable. And it wasn't just a bunch of nerdy scientists in obscure journals like Science, right? Here's Bill Gates, gave a hugely popular TED Talk seen by tens of millions of people in 2015. The next outbreak, we're not ready. CNN, 7 reasons why a global pandemic is inevitable. 7, right? You only need 1, but it's 7 reasons. These are a major motion picture, right? With Matt Damon and Lawrence Fishburne, Gwyneth Paltrow, Kate Winslet talking about this. And finally, we have Time. Warning, we are not ready for the next pandemic. And sadly, that turned out to be totally true. We weren't ready. Despite all of these warnings, we weren't ready. So I want to take you back to the early days and kind of refresh our memory. You know, January 9th was when the WHO announced a mysterious coronavirus related pneumonia in Wuhan, China. January 20th, so pretty good, actually, pretty fast, the CDC says 3 U.S. airports will begin screening for coronavirus. We're going to come back to that word. January 21st, the CDC confirms the first U.S. case in Washington state. And then January 23rd. It's a Thursday, it's 10 a.m., and the entire city of Wuhan, a city of many millions of people, is put under quarantine. This is, at that point, the largest quarantine in world history, right? This is unprecedented to put so many people under quarantine. And this was when I began to freak out, right? Because my view was that, look, if anything, the Chinese are probably more concerned about the state of the economy than sort of the people, right? And so I figured if they are willing, if the Chinese are willing to take such extreme consequences of hurting their economy, right, to shut down major parts of their economy, we have to take this seriously. This is a really big deal. The Chinese are willing to do this. This tells us this is a big deal. And can we avoid it? Like, it seemed like almost impossible at that point. On the same day, the WHO actually said that the outbreak is not a public health emergency of international concern. That was surprising. A little bit later, January 31st, the WHO issues the PHEIC. February 3rd, the US declares the public health emergency. And this is when really the CDC in particular begins to fail. So let's go back to January 20th. Remember, I said that 3 US airports will begin screening for coronavirus. Now, what is this screening? Well, first of all, it's not a testing, okay? They're being screened, but they're not being tested. They're just being told to go home, go home and quarantine, okay? Not even the passengers who are coming from Wuhan, not even them are being tested. And moreover, this is from Michael Lewis's book, when local health officers set out to find these possibly infected Americans and make sure that they were following orders to quarantine, they discovered that the CDC officials who had met them upon arrival had not bothered to take down their home addresses. Unbelievable. Unbelievable. Had not bothered to take down their home addresses. Now, remember again, January 21st, I mentioned that the CDC confirms the first US coronavirus case, which is in Washington State. It's just north of Seattle. And it turns out that Helen Chu is an infectious disease expert in Seattle. And just fortuitously, she's been running an experiment. She's been collecting nasal swabs from people with flu-like symptoms from the area for months. She doesn't know anything about SARS-CoV-2. This is totally new. She was doing this for some other reasons, to study the flu, but she's collected all these swabs, okay? And she says, listen, let's go back and back test. Let's test all these swabs I already have. They're right here. Let's go back and test them for SARS-CoV-2. And the CDC and the FDA say, no, you cannot back test. Now, this is not some, wacky conspiracy theory. It's the New York Times. Lab push for early tests. Federal officials said no. Well, Helen Chu is going nuts, and she's saying, we got to do this. Look, this is getting out of control. More and more people are getting infected. We need to find out what's going on. I have these swabs. Let's test them. Finally, she actually defies the CDC and the FDA heroically. And she starts testing on February 25th. And she immediately finds a positive sample. It's a teenager. She informs the local health officials. They go and they stop the teenager just before he's about to enter high school, and they put him under quarantine. They meet later that day. Great job, Helen Chu? No. They gather that day with representatives of the CDC and the FDA to discuss what happened. The message from the federal government was blunt. What they said on that phone call very clearly was cease and desist to Helen Chu. Dr. Lindquist remembered, stop testing. Stop testing. Then remember January 30th, a little bit later, the US government had actually evacuated 57 Americans from Wuhan to the Omaha National Guard base. And it turns out, again, just fortuitously, that next door to the Omaha National Guard base is the Global Center for Health Security. Now, this is a world-class center for pandemic response. And it's led by this guy, Dr. James Lawler. And he wants to test the evacuees. Now, who is this guy Lawler? Is he some country bumpkin doctor? No, okay. He's a commander in the U.S. Navy. He's an infectious disease physician. He's responded to multiple infectious disease emergencies around the world. He was the U.S. military expert on Ebola. He's briefed the chairman, the Joint Chiefs. He served under President Bush in the Biodefense Council. He served under President Obama to coordinate national policy for the 2009 H1N1 influenza pandemic. So he's like totally the ideal guy to do this. And the CDC forbids Lawler from testing, even though every single one of the 57 Americans held in quarantine, they want to be tested. They say no. Now, this is not just hindsight. The Germans are also evacuating, as well as other countries, but the Germans are also evacuating their citizens from Wuhan, and they test them. And they write, we discovered that shedding a potentially infectious virus may occur in persons who have no fever and no signs or only minor signs of infection. So asymptomatic spread is right there, right from the very beginning. The Germans have tested them, Americans have not. 57 Americans, they're sent home without being tested. And James Lawler later says, there is no way that 57 people from Wuhan were not shedding virus. Now, the CDC's primary job was to rapidly produce a SARS-CoV-2 test kit. That is their main job. That is their primary job, produce a test kit. And on January 13th, the WHO had already posted a protocol for a test which had been designed by a German firm. Now, the CDC could have used this protocol, but they decided to design their own test. And in designing their own test, the CDC violates standard laboratory operating procedures, and they contaminate their own test. And this sets the US back by weeks. Now, it's true that at the beginning of any battle, there's going to be fumbles. Okay? But each of these errors, which are to be expected, illustrates a strategic mistake, a much more serious strategic mistake. And that is the CDC never had a plan for widespread testing. They never had a plan for widespread testing. And the reason that is because the only way that widespread testing was going to happen was if the big private labs, the ones who do all of your tests when you go to the doctor and the doctor says, get this blood test, those big private labs were the only ones which could scale up to do widespread testing. The CDC labs were too small, they were unequipped, they could not possibly do widespread testing for the United States. So the CDC plan couldn't work even if there had been no errors. And instead of widespread testing, the CDC policy was that it was the monopoly supplier of test kits and testing. So at the beginning, they said, only we can run SARS-CoV-2 tests. And they refuse to supply private labs with samples of the virus, to help them develop their own test kit. It's not our job, says the CDC. That's up to them. That's not our job. Incredibly, the CDC even demands that the private labs respect their intellectual property. And they engage in weeks of negotiation with lawyers over using and building on their test. Incredible. The FDA was also not without blame here. As we'll see, the FDA did some good things, but especially at the beginning and at the end, actually, the FDA was not, also made strategic errors. And one of these concerns these laboratory-produced tests. Now, ordinarily, laboratory-produced tests are not FDA regulated. They never have been. And it's routine, in fact, for labs to develop new tests without FDA approval. The FDA sort of claims authority, but that's never happened. That's not normal. And in fact, Paul Clement and Lawrence Tribe wrote an article about this in 2015. Now, if you don't know, Paul Clement He was like the Attorney General under George W. Bush or George Bush, I think. So he's a very well-known conservative legal scholar, respected conservative legal scholar. Lawrence Tribe is perhaps the most decorated or most well-known constitutional lawyer in the United States, particularly on the liberal side. So you have a major conservative and a major liberal lawyer, highly respected. And they argue that, quote, the FDA's assertion of authority over laboratory developed testing services is clearly foreclosed by the FDA's own authorizing statute and by the broader statutory context. However, the FDA uses the declaration of emergency to say that now that we're in an emergency, you have to have pre-approval to develop a SARS-CoV-2 test. So this completely inverts the logic of emergency. In an emergency, you should be lifting regulations and moving more quickly. Instead, the FDA is adding regulations and slowing things down. And here, incredibly, is what Clement and Tribe warned about. This is 2015. Here's what they warned about. The FDA approval process is protracted and not designed for the rapid clearance of tests. Many clinical laboratories track world trends regarding infectious diseases, ranging from SARS to H1N1 and avian influenza. In these fast-moving life or death situations, awaiting the development of manufactured test kits and the completion of FDA's clearance procedures could entail potentially catastrophic delays with disastrous consequences for patient. Disastrous consequences for patient care. And that is exactly what happened. Clement and Tribe nailed it in 2015. Now, each of these errors was small, but in the context of an exponentially growing virus, they were deadly. And this is what I call the original sin of the pandemic. And again, it's not hindsight bias. South Korea and Germany were producing hundreds of thousands of test kits, even as the CDC was struggling to produce hundreds of tests a day. In fact, in South Korea, the South Korean government, right early on in the pandemic, they called all of the potential test manufacturers together. And they said, come to Seoul train station. They didn't even bother to get to a hotel or something like that. They met in a room at the Seoul train station, and the government said, start producing tests right away. Don't worry about approval. We'll approve them later, okay? And we're going to buy lots of these tests. Don't worry about that. And by the way, if you need samples of the virus, we'll make access available to you of all these hospital patients and samples so that you can develop your test. So it was the CDC and the FDA's failure to rapidly ramp up testing. This meant that by the time that testing got going in late March, contact tracing and suppression of the virus was no longer a viable strategy because the virus was everywhere. That's the original sin of the pandemic. Now, let's turn from some bad news and some depressing failure to a success, okay, something which we did do right. And that was Operation Warp Speed. Now, to understand the context here, you have to understand that ordinarily a vaccine manufacturer, they're not going to start building a plant to produce that vaccine until they know that the vaccine works and then it's been FDA approved. Only then are they going to start building the plant. So that means that you get the vaccine approved, and even then you've got to wait, months or years before you can actually start producing the vaccine. So the idea of Operation Warp Speed had a bunch of different parts to it, but the idea was this. First, it guaranteed sales for approved vaccine. You get the vaccine approved, the government's going to buy the vaccine, even if COVID goes away. That was important because in the past, You had things like Zika and things like this, where the manufacturers had started to produce the vaccine, and then Zika went away, and the government said, "Oh, we're not buying any." So they gave them guaranteed sales. It paid the firms to run the clinical trials. It's important. It's the most important aspect, most expensive aspect of developing the vaccine is running the clinical trials. And it gave them lots of money to run the clinical trials, which made that you could have big trials, and big meant that you could go fast. You could get your results fast. It lifted a whole bunch of FDA regulation so that, for example, the trials could run concurrently. And it paid firms to start building the manufacturing plants immediately. So this meant quite possibly that some money would be wasted if you build a plant and then the vaccine that plant is designed to produce is not approved, it doesn't work, then you've wasted some money, but that was okay. Because we wanted, the benefit was that if a vaccine was approved, you had the factory ready to go. So that was critical. This was proposed by Robert Kadlec and Peter Marks to Alex Azar, Secretary of Health and Human Services. It was supported by Jared Kushner. It was authorized by President Trump. It was led by Moncef Slaoui, who was a pharma executive with expertise in vaccines, and by Gustav Perna, who was a general with expertise in logistics. And I mention these names very specifically because these people, I believe, have not been given the credit that they deserved. You know, in a better age, I think they would have been given a ticker tape parade in New York City to celebrate saving millions of lives. Okay, so they deserve a huge amount of credit. Now, Operation Warp Speed, it didn't come out of nowhere. It was actually backed by a lot of previous academic research and practice. Most notably, Michael Kremer, Nobel Prize winner in economics, and Rachel Glenister had written this book in 2004, advocating for advanced market commitments. And not only had they written the book, but they had put the ideas into practice. They had created, along with Bill Gates and government support, but they had created an advanced market commitment for the pneumococcus vaccine. And they had gotten firms to produce that vaccine, vaccinated millions of people who would not otherwise have been vaccinated, and saved 700,000 lives. Incredible, incredible achievement. Also, the Council of Economic Advisors had written, again fortuitously in 2019, a paper on the potential cost of a pandemic, pointing out that this could cost trillions of dollars. It was also the case that the Council of Economic Advisors was well aware of the potential cost of FDA delay. Because Thomas Phillipson, who was the head of the CEA, he had written on this topic, along with Eric Sun, who was also at the CEA. This came out of work from the University of Chicago by Sam Peltzman. I had also done work on this topic. And indeed, this is where sort of I came into the picture, because I was called up very early. I was called very early on in the pandemic and asked to give a talk to the Trump White House, to the Domestic Policy Council and the Council of Economic Advisors on using incentives to accelerate vaccine production. And I get on the call, and Cadillac and all these guys are all CC'd on the call, whatever. And it turns out that they've invited me and Michael Kremer, okay, the world's #1 expert on this topic. And I'm like totally forthright, and I'm saying, you got to do this, you got to do this. The economy's losing billions of dollars, every single day. And I was like, listen, I'm known as kind of like a conservative free market economist. I have never said these words in my life before, but now is the time to throw money at the problem. And I was talking about human challenge trials and FDA, lifting FDA regulations and all these kinds of things. And Michael Kremer turned out to be in complete agreement. Even on like the radical stuff like human challenge trials, he was in total agreement, which is fantastic for me because, gave me a lot of credibility. So after the call, they asked us to write a report for them. And Michael gets together a bunch of famous economists, his friends, top-notch economists in the world, people like Susan Athey and Chris Snyder and others. And together we write this report, first to the US government and the British government, and we become advisors to the World Bank and so forth. And what does the report say? Well, it says we can plausibly advance a vaccine by 3 to 6 months by spending, let's say, 100 billion, saving $1 trillion or more. Okay? And actually, this was it became pretty obvious that this was true as the pandemic went on, because every time you saw just a little bit of good vaccine news, the entire stock market jumps up. Okay? So the airline stocks jump up, the restaurant stocks jump up, and so forth. And it's pretty obvious that the vaccine companies, they're not going to be able to recoup but just a tiny fraction of the trillions of dollars in wealth which is at stake here. So it made sense to kind of subsidize to get the vaccine industry really going, because billions are much, 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 much less than trillions. Okay. And that was at stake. So we write in the New York Times, in the race for a coronavirus vaccine, we must go big, really, really big. So now let me say a little bit more about this. I won't get too technical, but you can't just say, like, go spend a lot of money. Okay. So you want to say, well, which vaccines should we support? How many, right? Should we just support 1 or 2 or 5 or 10? How many shots on goal is best? And you can see that, the more vaccine candidates that you support, the greater the probability you have at least one success. But that probability goes up at a diminishing rate, okay, as shown in this diagram here. And then you have the question, well, how much capacity do you want? Like, what size factory do you want? Okay, 100 million doses a month, 300 million doses a month, more, okay? More capacity is better, but it also has diminishing returns. Think about it this way. Suppose you have a factory which is producing like 100 million doses a month. Well, then you can vaccinate 1.2 billion people in 12 months. If you double your capacity, then you can vaccinate 1.2 billion people in 6 months. So you save 6 months. You double again from 200 to 400. Well, now you can vaccinate 1.2 billion people in 3 months, but you notice your first doubling saved 6 months of time. Your second doubling saves 3 months of time, quite a bit less, right? Also, your first doses are going to go to your highest risk population. So again, for these reasons, there are diminishing returns to capacity, right? So we build a model to kind of balance off these two diminishing returns, okay? And the upshot is, you run all the numbers, and it depends upon assumptions, but we come up with spending like 25 to 50 billion, invest in 18 candidates with a capacity of 300 billion vaccines a month. That's the kind of numbers that we're talking about. Now, what did we do? Well, the bad news is that the world did not go as big as we wanted them to go. Operation Warp Speed in the US was by far the best. They spent about 15 billion. The UK and Europe spent maybe 1 to 2 billion. The rest of the world, pretty much nothing. The good news is that what we did do was extremely valuable, extremely valuable. So plausibly, if Operation Warp Speed, advanced sort of 1 billion courses of the vaccine, okay, by a year, then it generated $2.4 trillion worth of value. So in my view, Operation Warp Speed had the highest benefit to cost ratio of any government program since, Manhattan Project, or since DARPA invested in the internet. That's the kind of scale we're talking about. Tremendously, tremendously successful program. Lots of bang for the buck. Now, back to failures, okay? So the interim, we had success, and back to failures. There's a bunch of things which we should have done, which we could have done, but which by and large, we did not do. We could have had an Operation Warp Speed for mass and test. We could have experimented and studied the virus to a greater extent. We could have done human challenge trials. We could have done first doses first, fractional dosing, early vaccines for the nursing homes. We could have invested more in rapid antigen tests. Okay, I'm happy to talk about any of these. Maybe we'll get some more of them in Q&A. I'm just going to say a few words today about the first three, and then we'll conclude and get to Q&A. So let's talk about an Operation Warp Speed for mass and test. Okay, there's a remarkable, just a remarkable series of email exchanges between Mike Bowen, who is an executive at Prestige Ameritech, is a large producer of surgical masks in the United States, and Rick Bright at BARDA, the Biodefense Advanced Research Development Organization Agreement, something like that. Okay, so he's kind of a key guy. Rick Bright and BARDA, key people at the pandemic. And Mike Bowen emails Rick Bright. This is January 22nd. And he says, we have 4 N95 manufacturing lines that aren't in use. Reactivating these machines would be very difficult and very expensive, but could be done with government help, like an Operation Warp Speed. January 25th. We're getting lots of requests for masks from China and Hong Kong. If China stops sending us masks, American hospitals could run out. Okay, so January 25th, he already sees what is going to happen. Bowen sees what is going to happen, and he tells Rick Bright at BARDA. January 27th, Rick, I think we're in deep shit, the world. Now, we didn't do this. We didn't do this. Now, Operation Warp Speed followed what I call the American model, which is in an emergency, you use the federal government to amplify the power of America's private sector, not to command and control, okay, not to take over, right, but to amplify the power, to use the incredible spending power of the federal government with the speed, the ingenuity, the capacity of America's private sector, to unite the visible hand with the invisible hand. That was what Operation Warp Speed did. It's a public-private partnership. You use spending. The federal government did not produce the vaccines. It did not deliver the vaccines. Okay, it did not administer, for the most part, the vaccines. You know, the pharmacies did. Okay, public-private partnership. The government spent, and they utilized the capabilities of America's private sector. But there was nobody in government. This is my experience talking with people in government. There was nobody in government who had this big picture of the American model in mind. So we got lucky in some places. We had someone like a Robert Kadlec who understood this, and he pushed Operation Warp Speed, and we got it for vaccines. But we didn't, it was random. We got lucky. We didn't do this as a general plan for how to deal with the emergency. There was no one in charge and no general understanding in the American government of the American model. That was my view. Now, again, you would think that studying the virus, you know, and developing stuff would be like the most obvious thing, okay? And here's an incredible, incredible story. The story of Fast Grants, which was formed by my friend, my colleague, my co-author, the guy who has an office just down the hall from me, Tyler Cowan, and the entrepreneur, Patrick Collison of Stripe. They raise a whole bunch of money very quickly, and they start giving the money out, okay, to people who are studying the virus, right? And they're giving out millions of dollars before the NIH had reviewed a single COVID grant. NIH did a lot of good stuff, a lot of stuff early on, and that's why we got, you know, the vaccine, but slow. Saliva Direct, which was the highly successful spit test from Yale, developed by Professor Annie Wiley, the Yale School of Public Health, just used by the NBA and then widely, would not have happened. This is what Ann Wiley says, would not have happened without FAST grants. Now, just think about like how insane that is. Like it still boggles my mind to this day, that like my friend with the office down the hall, he's the guy distributing money to solve, the COVID crisis. Like it doesn't make any sense. It doesn't make any sense. And to see like how bizarre this is, just like think about this a little bit more. Okay. Annie Wiley, she's at Yale. She's at the Yale School of Public Health. The Yale School of Public Health. And she cannot get money from her own institution, which is a school of public health, in a pandemic, and she can't get funding. She can't get funding. It's stunning. It's stunning. And if that doesn't like boggle your mind and make you angry, okay, notice the Yale University endowment is a $42.3 billion endowment. And they had returns of 40% in that year. 42.3, like Tyler Cowen does not have $42.3 billion. So why is he the one funding a researcher at the Yale School of Public Health? It's crazy, but it shows you that the rot was not just government. The rot was deep. The rot was deep. The inability to move quickly in response to a crisis. This was a deep, deep failure. Let's also talk a little bit about human challenge trials. So on going back again now, this is January 11th, 2020. This is when data on the genetic code of the virus is uploaded by Yongzhen Zhang in China. Kind of heroically, he uploads the data to the internet. And by January 13th, Barney Graham and his lab have designed a vaccine. Okay, they've designed a vaccine. 2 days. Everything else, pretty much, is testing. Now, standard field trials, they're expensive and they take a long time. So in a standard field trial, what you do is you take a big group of people, in this case, 30,000 people, 15,000 of them, you give them the vaccine, and 15,000 of them, you give them a placebo, and then you tell all of them, go out and live your lives. Do your ordinary thing. And then you wait. And you wait. And you wait until enough people have gotten COVID so that you can tell whether there was a statistically significant difference between the vaccine group and the placebo group. Now, in a human challenge trial, in contrast, you take 100 volunteers, you give 50 of them the vaccine, you give 50 of them the placebo, and then you expose all 100 to the virus. And you can get results within a week. Much faster, potentially much faster. Now, the National Institute of Allergy and Infectious Diseases rejected human challenge trials. So, quote, Dr. Fauci's office said the Institute has no plans to fund COVID-19 human challenge trials in the future. Many bioethicists support that decision. We don't ask people to sacrifice themselves for the good of society, said Jeffrey Kahn, director of the Johns Hopkins Berman Institute of Bioethics. And I'm like reading this and like, what? What on earth is this guy talking about? So someone near and dear to me on Twitter, bioethicist, we don't ask people to sacrifice themselves for the good of society. Also bioethicist, stay at home and wear a mask everywhere for the next 2 years for the good of society. Of course, we ask people to sacrifice themselves for the good of society all the time. It's what the police do. It's what the military does. It's what coal miners do. This is like a totally normal thing. right? Totally normal. So why the pushback against human challenge trials? And I think the answer is the omission commission fallacy, or sort of a status quo bias. And this is a fallacy which is deep, held by public and also by experts. So let's think about it in a sort of non-controversial context, which is in vaccines like prior to COVID. Now, here's how I think, and this has been argued, some people think about, should I give my child this vaccine? Well, if I give my child the vaccine and they get a, side effect, rare, but it can happen. They get the side effect. I will have harmed my child. I will have done something which hurts my child. It will be my fault. I will have given them the vaccine. It will hurt them. It'll be my fault. And I'm going to feel terrible, terrible if I do something to harm my own child. On the other hand, again, implicit thinking, if I don't give my child the vaccine and my child gets sick from the disease, well, that was bad luck. That was nature. That was ill fortune. But it wasn't something I did. It wasn't my fault. And I think a lot of physicians and bioethicists, they think the same way about human challenge trials. Because you take a randomized controlled trial, the big mass trial, right? And among those 15,000 who get the placebo, you're telling go live their lives, a bunch of them are going to get COVID. Maybe more than 50 than you're going to do with the human challenge trial, probably almost certainly more. But it's like, oh, well, that wasn't me. I didn't give them COVID. That was just, they were living their lives. That was just bad luck. It wasn't my fault. I didn't give it to them. On the other hand, if you have a human challenge trial and you expose 50 who have the placebo to the virus, well, then you are doing it, right? So if I don't want to be the one, I don't want to be the one. And my answer to this is, it's not about you. It's not about you. Take your emotions and your feelings, take that out of the equation and just do the thing which is best for your child, or do the thing which is best for society. I don't care that you're going to feel bad. That's not your role. You're not supposed to take into account, as head of the, NIH or the Institute for Infectious Diseases, we don't care that you feel bad. Just do the thing which is best for society. Do the thing which increases expected value. Be a utilitarian in this case. Get your feelings out of it, because it's not about you. It's not about you. Okay. So let me conclude, and then I'll open up to Q&A. The CDC failed in its primary mission, with consequent loss of lives. The FDA, they performed better than expected. They failed on tests, but they did have a big win by lifting regulations to allow Operation Warp Speed to move quickly. Operation Warp Speed was really the shining jewel of the pandemic response. It helped to produce a novel vaccine in record time, generating trillions in value. And Operation Warp Speed followed the American model. In an emergency, combining the financial power of the federal government with the ingenuity and speed of the American private sector, the American model is powerful, and we ought to be thinking more about the American model as we think about how to deal with future pandemics and also with future emergencies of a variety of kinds. Thank you very much.
Thank you, Alex. That was very precise, insightful timeline, very specific, gives us a good history lesson here too, for our students and us, and also some trends and general lessons, I think, to take from this as well. So we will, of course, as Alex said, open it up to questions here. For those of you new to WebEx, if you look at your, you should have a menu or buttons available on either the bottom or one of your sides. There is, I encourage you to type questions or comments in the chat message board, there's a button that looks like a little talking cloud that you can click on, and you should bring up your chat message board. And there is technically also audio capability. If you do want to use audio or feel you have good audio capability, you can raise your hand. There's a little hand icon that can note that for us as well. Do want to, as people are actually getting in some questions, maybe start with one. Actually, we have some coming in here, so maybe let's go to audience questions here. Let's see. So Celeste here has maybe a little more personal question. And this can allow us to get to know you better, Alex. Maybe given some of your history or something, was there anything specific that made you interested in this topic and how the pandemic impacted society? Obviously, this was one of the biggest societal impacts globally and domestically in human history, but just, that would obviously interest a lot of people, but maybe anything specific from your background as well. Perhaps you could elaborate on that to get us started here a little bit.
Right. So I've written for many years about the cost of FDA delay. The central idea being that, when the FDA approves a bad drug, a drug which has some later shown to have some safety problems, then heads roll at the FDA, right? And the FDA gets in trouble. On the other hand, when the FDA delays a good drug, they say, oh, we need more testing, we got to do more on this. Okay, it takes more time to develop this drug, raises the cost. When they delay a good drug or make it so expensive that the good drug is never even produced, then the people who die, who would have lived had that new drug been available, they die in what I call an invisible graveyard. They're hard to see. So I was always interested in pointing this out to try and get people to think more clearly about the costs and benefits of FDA safety procedures and so forth. Now, the pandemic stuff was really by accident. I mean, I was invited to give this talk, and I don't know exactly why he picked me or whatever. Maybe I was like to balance out Michael Creamer or something. I'm not sure. But because I gave this talk with Michael, and then they asked us to write this report, this became my life for the next 2 years or so. So it was really just came out of that.
As you are an economist, Alex, studying the economic incentives and the cost benefits of this, as you said, is very obviously very important to you. Anne has a good question here. How would you characterize? You obviously talked about the economic, or mentioned especially early on in your talk, the economic impacts of the pandemic, of course, and many of us are familiar with that. How would you characterize more specifically the economic impact of anti-mask sentiment and vaccine hesitancy throughout the pandemic? That's maybe speaking more to the American population, of course, more generally, which is, so I'm not sure if you have any to elaborate on that, but we'll throw you that question here.
Yeah, no, absolutely. I mean, we made policy mistakes, the government did, but then the American public has made mistakes as well. And it's just been incredibly tragic to me to see people dying unnecessarily. Once the vaccines were approved and were widely available, hundreds of thousands of people have died, unvaccinated people, and they didn't have to die. They did not have to die. And it's just a tremendous tragedy that the whole issue became so politicized. So we have not been well served by our political leaders who, on both sides, before he was president, Biden and Kamala Harris sort of said, well, I don't know if I can trust the Trump vaccine. Okay, I don't know if it's going to be approved too quickly. We don't know if we can trust the Trump vaccine. So these sowed some vaccine hesitancy. And then, of course, it became with the mandates, which I think were probably a mistake. A lot of people reacted to that. Don't tell me what to do, right? And instead of treating people like adults, we started to try and force them into doing things, and people reacted, and it became politicized. And then the mask issue, there were multiple problems on both sides. Again, at the beginning of the pandemic, Fauci and others said, don't wear masks. They're useless. They're not going to work. Okay. And that then, of course, later flip-flopped. And, it's unclear whether they changed their minds or whether they were telling a noble lie to try and keep more masks for the hospitals. But I think the communication there was not good. So there were huge, huge numbers of failures, both from the political leadership and, from people in general. It's been very, very sad and tragic because people have absolutely died who did not need to die.
And maybe going off of that theme a little bit, Alex, I'm going to sort of take Michael's question here, which is a good one, and maybe sort of expand it a little bit. He asks about, if there are not as many errors in in some of our government agencies, including the CDC, would there be better outcomes here? I mean, this gets to our lessons learned, hopefully, and I don't know how much we're learning our lessons, but maybe I can expand that a little bit. If I may summarize a little bit, there's a consistent theme here, it seems, and that is in what is an obvious, time is of the essence emergency situation. We have slow moving, lethargic, bad decision making organizations and government agencies included in that. This may be a difficult question to parse out, but how, going forward, how much of it, and I imagine you'd say it's a little bit of both, how much of it is attributable to just bad or over regulatory structure, or how much of it is attributable to the individual actors within the agencies? Meaning that if we somehow got more ideal decision makers, so to speak, are we still slower potentially than South Korea or Germany or otherwise? Because our regulatory structure or the culture at these institutions does not allow for individual actors to act within what would be a more reasonable, fast-paced sort of time frame, if you understand the question here.
Yeah, yeah. Yeah, I mean, I think it's a very good question. So let me answer this first with a controversial statement. I think gets at some of it, and then I'll expand a little bit. The controversial piece is I don't think Operation Warp Speed would have happened under another president, under Biden or Obama or something like that. What they would have done, they would have been they would have been way better on many other issues. Okay, communication to the public, Trump was terrible. Lots of terrible things that Trump did. It was very, very poor. But the idea of Operation Warp Speed, of giving billions of dollars to private firms and of blowing by the ordinary regulatory process, I don't think a Democrat president would have done that. They would have said, well, we got to do it by the book. We got to make sure that every, T is crossed and every I is dotted. We have to reassure the American public that we're doing this 100% by the book. That they would have been it would have been a different story. And again, they would have been better in other respects, but on that they were not. So I think there was definitely some scope for a personal, who was in charge mattered. And somebody who was willing to kind of use the power of the executive to push things faster. That was possible. But the problem is that is totally random, right? It is random who is in charge when a emergency like this happens. So I think we don't want to sort of rely on that because it can go either way. So we do need our institutions as a general rule to be more quick on the ball and less legalistic and less bureaucratic, particularly something like the CDC. And I think part of the problem was that, America had gotten lucky for 100 years. We'd had a pandemic, and a terrible one, in 1918, and then we just kind of gotten lucky. It happened elsewhere in the world, avian flu and things like that. But they kind of petered out, fizzled out before they really got to the United States in a big way. So we lost that muscle memory. We lost that ability to move quickly. The only institution which seems to retain some of that is the military. And I'm not like happy about this, actually. I'm sort of more of a pacifist kind of guy, but kudos where kudos belong. Like without the military aspect of Operation Warp Speed, it would not have happened. it would have not have happened. So, and why? Well, because we do ask the military to do things quickly. So they still have that muscle memory, right? Whatever you think of the military, you can't ask them to, invade Afghanistan, and they'll have done it, within 8 weeks. So how long it took us basically to take Kabul. So the American military is one of the few institutions in our society which still gets practice at moving quickly. But I think we need to expand that if we're to be ready for future emergencies.
Yeah, no, it's certainly a lesson to, understand our regulatory agencies better, just general public, so to speak, and understand what is happening here, because it is so important. And we see you use the term stunning, I think, at one or two points in your talk, and the reasonable estimated loss of life here because of delays such as this for me, is, what we could also put maybe the term stunning on that too. It really is something, and something we need to be concerned about. Maybe another lesson to draw from here, and for our students, is at the start of a pandemic, screening and testing. You mentioned that at the start of your talk, and that's obviously important. And that's something that, say again, maybe like a South Korea excelled at, where we didn't necessarily even at all. Do you have a sense, having been at least a little bit close to this, talk about the potential? These things are very unpredictable. Possibility of a future pandemic, especially in our students' long life ahead,
Yeah.
decades ahead. What the status of this is? Is there any evidence that we are more prepared on this initial screening and testing start of a pandemic side, than we were, what's a pretty abysmal response, to be frank, I
Yeah.
suppose,
Yeah.
this one, the previous one.
Yeah. Yes and no. So a few good signs, like, we had the monkeypox scare, which has fortunately diminished. It, went way up, and then it is crashed back down again. And we did things there more quickly. We did first doses first, which I had advocated for COVID, but the United States did not do. But a bunch of people did first doses first when it came to monkeypox. So that seemed to, the experience with COVID did seem to have helped to justify more radical and quick actions when it came to monkeypox. So maybe, but then if you look at the big picture, there is a pandemic um, bill, which we still have not passed. Just like amazing to be stunning, as you used. Like, I can understand not passing a pandemic response bill before the pandemic. I mean, it hasn't happened for 100 years. It's, something that you can avoid. It's, one of these things which is important but not urgent, right? And so people don't do it. But after the pandemic, we still have not passed this bill. That's crazy to me. And I think there are things that we can do. So going to your point again about people versus institutions, I think we should be looking for sort of emergency alarm systems, which are not the type where someone has to pull the alarm, but which are more automatic. So what I have in mind in particular is one thing which turned out to be surprisingly useful was the surveillance testing of sewage. So I think every major sewage plant in the world ought to be running tests for a variety of unknown viruses. Okay, just automatically, and just put that like up on the web. And this is what I mean by sort of an automatic, just as a routine method, we should be gathering data from sewage. And this is like cheap. It's easy to do. It doesn't require a lot of high technology. These times of tests are getting cheaper all the time. So that would give us a little bit more of an early warning, which is critical. And we ought also to be starting more vaccine research before. So, we do have right now this H5N1 flu, which is affecting minks and now wolves or lions or something like that. So it's affecting mammals, and we're frightened that it could jump to the human population, where it is very, very deadly. We ought to be developing at least the first stages of vaccines for that type of virus, which is totally, again, technically possible. So anything you can do to accelerate the vaccine production that was like the number one thing. So that's incredibly important.
It's a key point. Perhaps some regulatory reform, the hope for that somewhere to make these things more automatic, so it doesn't rely on the individual actors. I say the institutional and individual level too, because we have a lot of sociology students I know here in our session, so we talk a lot about the different levels, of course, and so that's we try to parse those things out when we analyze big issues like this. Alex, it's been wonderful. Do you have time maybe for one or two more questions? Is that okay?
Sure. Sure.
You didn't get to, I don't think you got to fractional dosing that much necessarily. And perhaps could you elaborate a little bit on that concept? Because, you know, for those that don't know, fractional dosing is basically, okay, so Moderna, has a vaccine, they recommend a certain dose. But if you say cut the recommended dose in half or by a quarter, into a quarter, you can likely still get a high protection efficacy, meaning you can prevent still against death or against serious infection, but because you've split it in half or a fourth, you can immediately vaccinate more people, 2 or 4 times more people. It's a timing, in an emergency situation sort of strategy. You've advocated, I believe, a lot for that, if I'm correct. Any understanding either globally or within the US if that's gaining any traction, the idea, again, in a potential future pandemic, if anybody's taken on the idea seriously of potentially fractional dosing, and doing
Yeah.
I mean, because hopefully, I mean, whatever our opinions and backgrounds on these issues are, the goal should be to save lives, right? I mean, that's the ultimate goal. And fractional dosing seems to be a thing where you can instantly save a lot more lives and then get to more higher efficacy later. So maybe you could speak about that a little bit.
Yeah, exactly right. So there is a number of dose stretching policies. One, fractional dosing, which you mentioned. The other one was first doses first, which I was a big advocate for, and that was, the coming out of the clinical trials. The first dose, the way the clinical trials work, was given. You gave the first dose, and then 3 or 4 weeks later, you're supposed to give the second dose, right? And I said, look, the first dose, it's already protecting at like 80% efficacy level. So let's give out more first doses and delay that second dose, to 8 weeks or 12 weeks. And the British did this, and eventually Canadians did this. We didn't do it in the United States. But getting out more of those first doses out more quickly, I think, could also have saved lives. Again, the same ideas as fractional dosing. And these ideas are not so radical. So we have used fractional dosing in the past, to combat yellow fever. When you don't have enough, it takes time to build these factories and produce enough vaccine. So if you don't have enough vaccine, fractional dosing can make sense as a way of, tamping down and preventing transmission, perhaps, and kind of protecting more people. But also, there's a chance of sort of, as I said, sort of a ring vaccination or preventing. So if you could vaccinate a lot of people immediately around someone who might have spread it, right? So you vaccinate lots of people quickly, then you can even tamp down on the spread of these things. So all of this are just strategies and things to do to move more quickly. And like why we didn't do it, there was a lot of, again, bad kind of metaphors, and people said, well, that's not following the science, right? Because it wasn't true at all, right? And there was a lot of fear, and again, a lot of kind of status quo bias, right? So status quo bias, there's been a bunch of interesting experiments where even the way you frame the question, if you say, well, currently we're doing X, should we do Y? And then people are more likely to say, no, stick with X. If you say, currently we're doing Y, should we do X? No, stick with Y, right? Or if you give it to them open, here are 2 choices, X or Y, right? You get different results in all of these cases because just expressing something as the status quo makes more people choose it. And that's not really rational in most circumstances. And I think we got, because that was the way the original clinical trials had been done, we had to stick with the status quo, but that really what didn't make a lot of sense.
In an emergency, hopefully we can throw out the status quo a little bit, right? Maybe that's a
Yes,
shorthand lesson for it. Yeah.
absolutely. And look, you have to experiment in an emergency. You got to try different things. So like one reason for doing first doses first is if it didn't work, you could always go back and you learn something, right? You learn, oh, I've learned it doesn't work. Then you go back and you do the original thing. Okay. But if you don't try, then you don't learn anything. Right. So like if you're in an emergency, is it typically a situation of great uncertainty. And the way you deal with uncertainty is you have to experiment. You've got to try a whole bunch of different things. You got to move through the policy space, right? And try things until you figure out what actually does work. Right? And if you're just sticking with the status quo because you're afraid, you have status quo bias and you're uncertain and you don't want to, you're afraid of making decisions, well, then you don't learn. And learning is exactly what you need to do in an emergency.
And when you're in a status quo bias, it can also in some ways lead to the relative lethargy too, perhaps, and the relative slow moving when you're not in an experimental mindset and that sort of thing.
Absolutely.
So these are good lessons for us. Maybe we could wrap up here with sort of a summary question. I may go off of Mohammed. Mohammed has is in one of my classes, has a question here from earlier. There are lessons here of regulatory reform focusing on, maybe some well, I shouldn't say experimental, but ideas like fractional dosing, these things. If you had the ear of the current administration, if you could, if you could uh, advise the American population on what are the key things to focus on for future pandemics, is there a way to sort of summarize? I think you've already mentioned this, so maybe it will act as a good summary again of the top items essentially that you would, you're right in the taxi cab,
Yeah.
sort of summary. What would it be to just the government and the American population in general for
Right.
pieces here?
So on pandemics, I think what we've learned is vaccines, vaccines, vaccines. That really was the only thing which made a big difference. We spent a huge amount of debate and argument over mandates and lockdowns and masks. And that stuff was all, I don't want to say it didn't work, but it was all second order. Okay. It was all a lot of noise and all second order. The thing which really worked was vaccines. So kind of amazingly, as I pointed out, the vaccine was designed within 2 days. Now, how did that happen? Well, that happened not by accident, but because we had spent a lot of time and effort to supporting basic research, supporting basic science. So we had the tools on the shelf. We knew about mRNA, okay? We knew how to design a coronavirus vaccine from the SARS, from the previous coronavirus. So we knew some of that. And so that basic science really, really paid off, okay? And if we could then, the basic science paid off very quickly. Again, like we designed the vaccine in 2 days. So if we can then accelerate that testing process and the delivery process, that would make a huge difference. If we had, just to give you a final example, if we had, when the vaccines were approved, we already had millions of doses in stock. If we had been able to deliver those doses even a few weeks earlier, that would save thousands of lives. We might have even, so if we could have accelerated the testing, that would have saved many thousands of lives. If we had authorized those vaccines on a compassionate use basis before even all the results were in, okay, and say given them, say, to nursing home residents, that could have saved thousands of lives. So anything that you could do to accelerate the vaccines is tremendously, tremendously valuable.
Proactive viral research and vaccine vaccine development for these. And again, we got the bird flu thing going on, so that's certainly a lesson, as you said rightly, of course, that can be applied even even now, just shortly after our previous pandemic has essentially been winding down. So Dr. Tabarrok, this has been wonderful. Thank you for taking the time. I think there are a lot of great, really precise and very, but still widespread and general lessons for our students to take from this. I've certainly taken some as well. And thank you for taking the time to take questions from us here. We had some excellent ones, and you've really given us a lot of food for thought and an excellent timeline to think about these various levels and things for our just not only as students but also as citizens and residents of the country to think about how we think about these things and lessons learned going forward. So with that, everybody, we thank Alex Tabarrok for being here, and Alex, thank you for joining us here on the Global Studies Lecture Series, and thank you all too for being here in our session, and we'll see you all next time. So thank you.